Hello and welcome to week 4 of the pre-calculus class. This week you will be dealing with more trig, fun stuff, and you'll also be dealing with the conic sections. So if we look at the week 4 block, trigonometry in the conic sections. So you're going to click on here. All right, and if you notice here, it gives you the introduction and the objectives for the week. Okay, so as I said, we're still dealing with trig functions, okay, but now you're going to notice that we're not going to be dealing with per se right triangles. So we'll be dealing with non-right triangles, okay. And so if the triangle is not a right triangle, then there are different formulas. You have law of sines and law of cosines. All right. We'll be dealing with the polar coordinate system. So, and that's for the first part. That's dealing with the trig. Okay, and then the complex numbers to write in polar form, and then being able to add and subtract vectors. And then you get into the conic sections. So read the introductions and the objectives. If you go to the next screen, I have prepared, well, that's the reading assignment for you for chapter 6 and chapter 9, dealing with the trig in the conic sections. And then I have some lecture notes on both sections. We're going to start with the, just glance at it, the trig portion. The first part is dealing with the polar coordinates. Okay, and so the first question is, what are polar coordinates? So basically, you're going to see the notation, okay, in the form of r theta. Okay, now you remember the r from your right triangle or from the Pythagorean theorem. Okay, this is known as your hypotenuse. All right, so the point r theta can be represented in many ways. Multiple ways are below. Here are some ways r theta is the same as r comma theta plus 2n theta. Okay, or you can have negative r comma theta plus pi plus 2 pi times n. Okay, and so all of this would be your coordinate, okay, negative r in this, okay. And so we'll see how that makes sense. Let's go down further. How do the polar coordinates relate to the rectangular coordinate system? All right, so in relation to the rectangular coordinate system, again, we can relate this to the Pythagorean theorem, okay, where you have c squared is equal to a squared plus b squared. All right. However, in this case, we have x squared plus y squared is equal to r squared. It's saying the same thing, because we remember that we use the xy in reference to the cosine and sine. Okay. All right. Cosine and sine. Cosine for x and sine for y. Okay. So if you have sine theta, okay, remember that if we do the SOHCAHTOA, let's see if I can write this down. Hold on. Oh, here we go. The SOHCAHTOA, so you know that the relationship between sine, cosine, and tangent, okay? So opposite, okay, let's open this up. All right, so we have Saka Toa. Okay, we have, this is in relationship to a right triangle, okay, where you have sine theta is equal to opposite over hypotenuse, and then cosine of theta adjacent over hypotenuse, and then tangent of theta is equal to opposite over adjacent, okay? Because note that tangent is sine over cosine. All right, and so we can really look at this, okay, in relationship to how tangent theta is opposite over adjacent, okay, and then how tangent theta is sine theta over cosine theta, okay. So just to see that, we can see that if we do the sine opposite over hypotenuse and divided by the cosine adjacent over hypotenuse, okay. And to verify that, when we divide in fractions, okay, you have to flip the second one. So basically you have opposite over hypotenuse times hypotenuse over adjacent. And so what does that give you? We have the opposite over the adjacent. So that's just a check for you. That's showing you the relationship of sine, cosine with cotangent. Okay, the same thing can be done with cosecant and secant and cotangent. All right, so just wanted to make sure you're aware of that. All right, so let's go back to the lecture notes. No, that's not it. Okay, here we go. All right, so we have that sine of theta, and we're in the polar coordinates thinking now, okay? So sine of theta, we know that it's opposite over the hypotenuse, okay? And so in this case, the y represents, you know, the parallel to the y coordinate and the x to the x coordinate, all right? So we have y over r, or y is equal to r times sine theta. Just a different way of writing it. Cosine of theta would be x over r, or x equals r times cosine theta, and tangent of theta is y over x. Okay, and again, I said recall the acronym SOHCAHTOA to show the relationship. So we just finished playing with that. Also, I suggested it may help to have the unit circle with the degrees and the radians visible. This way, it'll help you, and then remember that the radius of a circle is 1, and the ordered pair is cosine theta, sine theta. This is your x and then your y. All right, so this is a unit circle for you. It gives you the degree form, the radian forms, okay, and the values for certain ones on the unit circle. So if we wanted to find the rectangular coordinate of the given polar coordinates, all right, and so we have 5, 90 degrees, okay. So the solution here, we have x is equal to r times cosine theta, okay, theta being your degree, okay. R is your radius, okay, All right, so if we go back up, this is your R and your theta. So we're just going back to the basic. The polar coordinate points are theta. So when they give it to you, the theta, they gave it in degree mode. So we'll just use R is 5 and theta is 90 degrees. So X is equal to 5 times cosine of 90 degrees, right? So cosine, remember, if we're using the, you can use your calculator, just make sure it's in degree mode, or look at the unit circle, okay? And so the value of cosine of 90, okay, cosine is the first one, so it would be 0, right? So the X coordinate would be 0, all right? And once you have the X coordinate, we can find the Y coordinate by using the equation. X squared plus Y squared is equal to R squared, okay? Because we have X, we have R, we just don't have Y. So now if we plug it into that, okay, and you work out the problem, you find out that Y is equal to 25. To find out Y, you take the square root, okay, of both sides, and so that means that Y is equal to plus or minus 5. Okay. Now, however, Y is equal to 5 because the radius is R is greater than 0, okay? Or we could have used the equation, okay, Y equals R times sine theta, okay, and again, use the unit circle, or plug the 90 degrees into your calculator. But if you go up to your unit circle, again, sine of 90 degrees, that would be the 1, okay? And so we have Y is equal to 5 times 1, which is 5. So the rectangular coordinates are 0, 5 for this X and Y. Very good. All right. Same thing with the with B. Okay, we're given the radius, and this time we're given the radian form. And so when given the radian form, again, we can still use the unit circle. All right. So make sure you look at the examples as far as how to do the radian form. You still use the same formulas. X equals R times cosine theta, and then find out what cosine of power of 6 is. Okay, if you go up here, those are the common ones. Power of 6 is here. The value is square root of 3 over 2. Okay, so that's all we're doing is using our references, all right, to find out the rectangular coordinates when you're given the polar coordinates. All right, so that talks about the polar coordinates, right? Now, as you are working with the homework, doing the homework, you will notice that, again, you'll be dealing with triangle, and they're not going to be all right triangles. As you can see here, these are non-right triangles. And what I'll do is give you videos with examples of how to solve non-right triangles. Okay, so as you can see, and it's not hard. It's just knowing what formula do I use, you know, for my triangles. Okay, so just giving you a look at the this is dealing with that we just did the polar coordinates. Okay, again, there are 16 questions in the first homework set. Okay, this is dealing with complex. Okay, complex number, the I. All right, so what we're going to do here is I want you to look at the notes on the polar coordinates. You're able to start the homework set for the first part, okay? And then I will show you examples of solving non-right triangles, okay? And if you have questions, please let me know.